Next, in continuation, uh, welcome to Teja Statistics. This is about the probability distributions and also the moment generating functions. So, how we are going to discuss this is very useful for the BSc semester 1 data science also. Let's see the accumulant generating function. The characteristic function c of a random variable x is denoted by phi x of t and is given by phi x of t is equals to expected value of e to the power of itr. So itx you can write. Okay. So the properties phi x of t is equals to expected value of e to the power of itx. So phi x of t imaginary value is going to be used here. So expected value of e to the power of 0 will become the 1. So phi x of 0 is equals to 1. Next, phi x of t is always modulus less than or equals to 1. So this will be the minus 1 and plus 1. You can see the definitions over here and the simple calculation and their proofs. Phi cx of t is equals to phi x of ct. Again, very important and previous year's examination question. Additive property of chi square and also phi x of t. Additive property of the characteristic function is given by the characteristic function of the sum of n independent random variables is equals to the product of their CFs. As you can symbolically we can represent if x1 x2 x3 and so on xn are n independent random variables, then phi x1 plus x2 x3 and so on xn is equals to phi x1 of t into phi x2 of t into and so on phi xn of t. Next, the proof if you see the proof values, so this can be easily calculated when the all powers are in multiplication, then you can add. Okay, here when bases are equal, power should be added. Here they are multiplying with respected to the it value. So as you can see, the e power it1 into e power it of x2 into e to the power of it of xn and so on. x1 x2 x3 and so on xn are independent. So when they are independent, we already have this formula phi x of t into phi x 2 of t and so on phi xn of t. Okay, effect of change of origin also we have to discuss. So this can be done as usual. By letting the u equals to x minus a divided by h. Consider the value and if you substitute u value, then you will get e to the power of minus it a divided by h is a constant. So here this also be the CF is also not independent of changing of origin and scale. So next, uniqueness theorem is also be the same. Okay. Next, probability generating function we have to see in this session only. So probability generating function, the PDF of a discrete random variable x is denoted by px of s and is given by px of s is equals to expected value of s to the power of x. Okay, s power x into p of x. Summation. So let x be a discrete random variable and taking the values 0 1 and with respective probabilities p0 p1 and so on. So this can be done in the following ways. Next, look at the properties of probability generating function. The additive property of PGF, the sum of n independent random variables is again a this probability generating function you can see. So p of x1 plus x2 x3 and so on xn is equals to e of s1 plus x1 s to the power of x1 plus x2 and so on xn. So when they are in addition in the power, they got to be multiplied. So expected value of s to the power of x1 into expected value of s to the power of x2 and so on. This is gonna be independent, so this will be proved. Next, if you see the effect of change of origin on probability generating function by letting the value, same property we are just using, that is the u equals to x minus a divided by h. Pu of s is equals to expected value of s to the power of u. S to the power of u is nothing but x minus a divided by h. X by h into s to the power of minus a by h is a constant. Putting outside, this value be an independent of change of origin but not scale. Okay, this is also be the PGF is also not independent of change of origin and scale. They are regularly asking this question in our examination. Try to learn easy concept. Okay, thank you.